So, thank you for this invitation. It is my pleasure to introduce you our research group. And what is my first and most important aim to be here? Of course, I would like to encourage you join us. So I will project several times, please join us. Okay, so here you can see the name of the research group, Cognitive Etho-engineering Systems, Cognitive Etho-engineering Systems and Robots. It is an interdisciplinary research group. We just established it under the umbrella. How can I? It doesn't. Yeah, here. Okay. Maybe. Okay. Under the umbrella of Neurotech EU, it is a European project, and our university joined this project. And under the umbrella of Neurotech, we established this research group. And what will be in the presentation? Of course, I will tell you something about the trends of smart devices. And according to this, I will tell you our goal. And something about the robotics and cognitive telemanipulation, what is our main interest in this research group. And of course, I conclude my presentation. So here is something about this Neurotech. So what is important here, it is a connection of neuroscience and technology. And that's why we are here. And look at here the main interesting disciplines in this neurotech: neuroscience, medicine, engineering, and artificial intelligence. It is your research interest. So please join us. We miss the expert of artificial intelligence. So please join us. And you can see cognitive science, robotics, and other things. I just copied from the web page of this Neurotech. Connect the neuroscience and technology. And here you can see the universities. This university alliance, you can find Debrecen University, but a lot of well-known universities you can find here. And so let's start. So what we are doing. And of course, we do something which related to the word smart. So that's why I made a quick research. Anyway, I did it several years ago, and I found smart energies, smart homes, smart homes. I don't know what does it mean, intelligent cake, but I could find in the internet. We like such words. And this is the important message. So, what is typical smart device? Smartphone, smart TV, smartwatch. What is important? There is no moving parts of it. So, from the engineering point of view, it's quite easy. But nowadays, we have to focus on smart devices, which includes moving parts. And after that, it is more difficult task. So maybe I have this phone, and make picture, and I can set this might shooting that we will not shoot if your eye is closed, and so on. Of course, there are a lot of calculation to recognize that whether your eye is open or closed. If the software has a mistake, I will delete the picture. But what would happen if an autonomous car make a mistake? Maybe we have to delete person from the list of lifelong person. So it's more serious problem, and we deal with smart devices, including moving parts. Especially our main focus is social robot. And here is our social robot group. You can see we have several members from the university. We miss the members from that faculty, maybe student or researcher, professor. And we have external members. We have Enjoy Robotics, so we have connection to industry, also other universities, and of course we have connection with Japanese universities and Norwegian company. So, first, what is social robot? You may know, so what is important, it should be independent. Should be independent, and maybe the most important and the most difficult part to interact with the human beings without bothering the person. It's very difficult. So we deal with waiter robot. And very important to show this robot that I am to serve you, but I don't want to disturb you. It is very difficult, and communicate and cooperate with people. So here is our mission. There was a character limit when we announced it. What is important? We would like to develop new paradigms of social behaviors, communication, intelligent system, including autonomous vehicle, robots. And what is important, we deal with non-verbal signal and maybe direct nervous system connection. So we don't want to deal with ChatGPT. So in verbal communication, we cannot compete with ChatGPT, but it's not enough. So we don't need a autistic robot. I am the robot, and without any emotion. So when we communicate, the meta-communication is very, very important. So without meta-communication, it's an autistic person, autistic robot. We need something else, and this is the non-verbal communication. And the other part, this direct connection to the nervous system. You know the movie, and where we inside this keyboard. So we may create keyboard. I don't know whether it's dangerous or not, but we started. Okay. And so here is I will show you just examples. Emotions. How can we visualize the emotions? We have some very complex model, and so we have several research directions for that. But what is important, we have the robot, and we would like to express the emotion robot with some in the screen. Or maybe we put a robot at tail and wagging the tail. I don't know. That is one target of research, which is the best for meta-communication to show that. So, for example, if we work together a robot, we have to hold something. And I show, oh, it is a little bit heavy, difficult to move. They have to communicate when they cooperate with the robot. Also, we have cooperation with the industry. Anyway, employee robotics use ChatGPT. So when you communicate that robot behind the communication with ChatGPT. But it is a little bit out of our research interest. And here, my usual question that, do you know what was the first human-created robot? And when was it created? And when a robot has emotions? So do you have any guess how many years ago was created the first robot? Okay, I will answer. So I just will tell you some parts of research. Also very important, how the robot should look like a human being. That is the trend in Asia. Anyway, I spent a lot of time. I spent 2 years in Japan, in Tokyo University, and after that, every year before COVID, I returned back to Japan. And unfortunately, after COVID, I had a chance this year to visit Japan again. So they would like to create really human-like robot, but is it a good direction? Here is this uncanny valley is a well-known effect. Anyway, do you know what is this uncanny? Is it the first time when you can see? So what is important? It's something a little bit similar to the human being, you can say cute. But when it is almost human being, you cannot decide whether it's human being or not. In this case, you have a bad feeling. So you don't know. So if you have a locomotive, you have no relationship. But if you have some eggs, some mouse, and you can say it is cute. But when it is getting close to the human being, so for example, what is the most ugly thing? For example, a dead person. We don't like the dead person because almost human being, but not human being anymore. So why we would like to create a human-like robot? So robots should be robot-like. And here is the extension of uncanny valley. I take the time. So we would like to introduce a new paradigm. And also, when we communicate with the robot, what kind of communication we need? A human-to-human communication. Of course, if I have a human-like robot, I will use this human-to-human human-to-human communication. But the robot is in my level. Is the same important person as I? No. The robot is below us. The robot should serve us. And but we have to include in somehow. And that's why we turn to dog. We like the dog. The dog can be the member of the family, but a little bit different than my wife. Significantly different. Okay. So we deal with ethology. Ethology is the science of animal behavior. Maybe you know it. So that's why we started this etho-communication. So not communicate like another person, we communicate like a dog. And in this way, we think the robot is a new artificial species. So we need this intra-species communication. And it is very important from the point of view of ethology. 3 days ago, I attended a lecture in the Hungarian Academy of Science, and an ethologist announced that there has big crisis in the ethology. So the ethology cannot improve. They use the same method as they used 100 years ago. So they need something else. And what they use, analysis. Analysis is important, but they would like to turn to synthesis. It's more interesting and of course more challenging. So we would like to create a new artificial species, of course with the cooperation of the ethologists, and we would like to create new behavior. So the robot should be robot-like and should behave like a robot. Do you know how the robot should behave? I don't know. That's why it is a basic research, what we are doing now. And here it is again the question. So do you know what was the first human created robot? And when was it created? So maybe a guess. How many years? More. I can say not 50,000, but maybe 20,000 years ago. Because we can consider dog as a biorobot. So what is the definition of the robot? Serve the human being and autonomous. So we can consider dog is a bio robot. So that's why we use this synthetic ethology after domestication of the dog. So the domestication is the creation of the dog, but instead of domestication, we will create robots, and this is synthetic robotics. And okay, so I have to keep the time. That slide is also important. What we are doing, we ask the ethologist, please observe the human-dog communication interaction. And then they can describe in an ecological way, I mean verbal model. So they say, okay, the dog has stress if the owner somewhere else and not in the room. And they can state such rules, and we try to convert it to a mathematical way. So we try to describe it in a mathematical form. We build to the robot and see what the robot will do, and usually something really different. And the ethologists say, oh, it is not dog-like, it is not dog-like, because they missed some important rule, which the dog knows, but when the ethologists told us the rule, they not thought that it is important. But when we buy in a robot, it really just follow the all rules we give them. Of course, it turned out something missing. So we had a long time to develop this model. Anyway, we dealt with attachment model, and and it was a long time that, so we had a model, we put in the robot, and the ethologists say something missing. They search for a new rule, we put in the robot, and finally we can state that we have, we call it Etho-motor, which can describe the attachment. It is based on the this stage situation test. I have no time to tell you the details. Anyway, we have this model. We can put in the robot, and not only robot, in the mobile phone. So the latest person very attached to the mobile phone. And we can do it vice versa. So we can put this Etho-motor, and in this case, the mobile phone also attached to me. This is a new thing. Okay, and let's go further. So this is the test for the attachment. Here is an important thing. Usually, as an engineer, we describe this state space differential equation. We use similar for the ethologist, but the input is a stimulus, output is the behavior. And we use internal states to describe the system. So we have a fuzzy system, a fuzzy state machine for describing the let's say usually the inner states, and then we have a behavioral fusion which finally decide the actual behavior. Here you can see some inputs. So the distance from the owner and from the toy. So the state, there are some hidden variables like stress and I would like to show you, okay, here is a MATLAB simulation. You can see how many inner emotional state we have. We have a rule for calculating the inner states, and in this case, robot, or in this case only in the simulation, can behave as a dog. And here, that was maybe. So it is. Következő. Okay, so this attachment behavior description video is missing. I have several other videos, and also and yeah, very briefly. So a very important message. Can a robot feel emotions? We don't know, but it is a wrong question. The good question, whether the robot can behave as we think that it has emotion, so the robot like us. So it doesn't matter whether the robot like us. The important, I feel that this robot like me. And also the thing or dog like the owner. I don't know whether it's true or not. For the owner, very important, this dog like me. And that's why we would like to learn from the dog behavior, or the dog can attract my love. And yeah, it is maybe an important message. And I just tell you, we have some other researches related to cognitive science. Sometimes we deal with sensory substitution. Also, this protesting arm. Here we use EMG sensor, but we can use also this EEG sensor. So that is also the real neuroscience. And we have other researches. We deal with mimetic algorithms, spiking neural networks, but we need your help. Please join us and help to develop that research topic. And so, yeah, my time is over. So thank you for your attention, and I hope you will join us. Thank you.